Hello everyone and welcome back to HeatShift, the SUSHEAT videocast where we explore the innovations shaping the future of industrial heat. I'm Cliò Agrapidis from RTDS and today we are shining a spotlight on one of the most exciting parts of the project, our new thermal energy storage system, or TESS, developed by the University of Lleida. TESS is a bit like a heat battery. It helps industries use heat more efficiently, reduce waste, and make better use of renewable energy. And the University of Lleida team is leading the design of an innovative, nature-inspired storage tank that could change how we think about storing heat. So let's dive in and learn what's new, what's exciting, and why thermal energy storage matters. I'm very happy today that we have Professor Carlos Mateu and Dr. Emiliano Borri from University of Lleida, and they will help us understand what the thermal energy storage is and what role it plays in the SUSHEAT ecosystem. So if you want to briefly introduce yourself very briefly.
Yeah,
Carlos.
I am Carlos Mateu. I am an associate professor at the University of Lleida in artificial intelligence and in the Greya group.
Yeah, and I am Emiliano Borri. I'm a researcher here, and I'm more focused on the energy part of the group. That our group is. It's quite a long time that it's working on developing new thermal energy storage solution for different application.
Yeah, thank you. So let's start from the top of what the University of Lleida or UDL contribution is inside SUSHEAT. What have you built for SUSHEAT up to now?
Yeah. In SUSHEAT, UDL is developing a new design for a thermal energy storage tank. We are designing a bio-inspired tank. That's a tank where the inner pipes that transmit the heat to be stored are inspired in nature. They are a tree-like structure, and the idea is not only design this new kind of tank, but also design it so it can be manufactured with additive technologies, with metal 3D printing. Our goal is to increase the heat transfer surface area so we can accelerate the heat release from the thermal energy storage to the system.
Great. And so, because we're talking about the thermal energy storage, but if somebody is not a specialist, it might not be clear what that is. So can you explain to us what does storing heat mean, especially in the scope of the decarbonizing industry?
Of course. So we are when we talk about thermal energy storage, that's why actually a lot of people call it heat battery. Sometimes, no, we call it thermal energy storage. There are some people that talks about heat battery. That's probably because there is an analogy also about the performance because in a thermal energy storage we can store a certain amount of energy, no, that actually represents the kilowatt hour or the megawatt hour if you go a very large scale, that it's the energy that we can put in this battery. And then, of course, depending on how we design the thermal energy storage, we can charge and discharge faster. That depends on the power of the storage. No, that's like the ampere, no, in a battery.
Yeah, thank you. So now we have an overview of the system and the thermal energy storage and what role it plays. And but what the University of Lleida is doing is quite unique with this TESS tank. So can you tell us what makes it new?
Yes. The novelty in our design is basically in the geometry. The thermal energy storage tanks are composed of a series of pipes that transmit a heat transfer fluid, be water, oil, whatever, and a tank that's filled with some material that will store this heat. Usually these tanks are designed as a set of pipes, are regular straight pipes, in our case, we are creating a set of pipes that are not straight pipes. They are a hierarchical structure, very, very similar to a tree, inspired by nature, inspired by our vascular systems, by our circulatory system. And the idea is that this new structure, this new geometry has a larger surface to transmit the heat without having to recur to use fins or other structures outside the pipes. This makes the area more effective, and the use of manufacturing systems like additive manufacturing allow us to create these very complex structures that cannot be manufactured in regular ways.
Thank you. Yeah. So in designing this kind of tank, there must be some kind of very specific problem that arises when it comes also to the performance you're looking at. So what specific problem in the performance did you decide to tackle first, if any, if there was something that happened as you were testing or designing?
Maybe I can answer. So, well, the thing is that in this type of storage that we are developing in the project, we are aiming to use what we call for thermal energy storage expert phase change material. Okay, so phase change material, well, it can be a material that any material that over a certain temperature, it goes from usually from solid to liquid, which is the most common example is water. So water, when it's in ambient temperature in a bottle, it's in a liquid form. When we put it in the refrigerator at 0 degree, it started to freeze, started to phase change. Okay, but there are also other examples that we can see every day. For example, like the coconut oil that sometimes we bought at the supermarket. If you go in summer, maybe it's liquid, and in winter is solid because it's a material, if we want to call it so, that at around 2021 change the phase. So what's the advantage of again this phase change material? That when a material is freezing or solidify, still we need energy to solidify or freeze the material. And this energy, when we want to recover it, is given back. Okay. The advantage is that during this solid phase transition, the material accumulates a lot of energy, more than when it's solid or liquid. What's the advantage of this? That if a material can accumulate more energy when it's solid liquid, we can make our battery smaller, so more compact. That, of course, in the case of our industry, this is an advantage to make this compact. But the problem is that for some material, I'm not talking about water, but there are other materials that can be used for other application. The power of charging and discharging this material, the power that this material can give to us is usually low. Okay, so there are several ways to overcome this limitation, and one of these is to build a good heat exchanger design, and that's what probably in this project is the main aim, to do a design and heat exchanger able to work with this kind of material that can increase the power that we are that the storage can charge or discharge to limit the effect of this material that has this low, we call it low thermal conductivity, actually.
Yeah, thank you for mentioning the phase change materials. They are also indeed a very key component of the design. In fact, you also had to test and decide which phase change materials to actually include and test within your bio-inspired design. And because this is for industry especially, there is also a requirement about the velocity at which this heat transfer can happen, correct?
Yes, definitely. Industry need a fast response. So if we have this heat battery, this thermal energy storage, and we need power very quickly, we need something that reacts fast. And if we have a material that releases the heat slowly, we need to find some solution, and one of that is the design that we are developing. Try to optimize this.
Yeah, thank you. So if I remember correctly, you had to do some small prototypes first, right? The lab testing. And what was your main purpose? Like, what were the things you mostly wanted to understand in the lab before you kind of could scale up to the full ecosystem deployment of the test tank? If possible to, like, because, like, this is also going to be, the SUSHEAT concept should be a TRL 5. So
Yeah.
there's going to be some kind of demonstration in the lab with basically data based on our industrial partners. And so you did the testing in Lleida, correct? And then it's going to be part of the rig in KTH.
Well, actually, this we in Lleida, what we do is we try to the first time was to do a proof of concept. As Carles said before, this is something very new. So for the first time, we wanted to do something like a proof of concept of this bio-inspired thermal energy storage that we are testing in the lab, a prototype which is very quite small because it's 3D printed. So it contains about 2 or 3 liters of material. Okay, so it's like a bottle of a 3 liters bottle, I would say. And this storage, we did a first design without any further optimization to see first if this concept is worth it. And to do so, we compare it with a normal thermal energy storage tank. That's usually a standard heat exchanger that is basically with tubes, and we compare with this branch with branch 3 design, and we have published a paper couple 1 year ago, more or less, to prove the concept, and we already saw that adopting this design without any further optimization, it give us very good results. And this was like a first step to then work on to understand if this works and start to be our concept. Of course, the simulation helped us, but then it's also Carles did all his work of optimization. I don't know if Carles, you want to.
Yeah, from that design idea, we started to use artificial intelligence to optimize the design. So the final placement of these branches and how the geometry of the fins of the pipes is constructed, how many pipes, how thick, etc., is designed by an artificial intelligence searching for the best heat transfer properties, for the best speed in discharge, and so on. So now we publish those results in simulation, and we are in the phase of building an actual physical tank that's designed by artificial intelligence. We'll test it in the lab, of course, and we are hopeful these lab results will align with the theoretical simulation results.
And so the next step, assuming this all aligns, then it's also to implement it within the full rig, correct? Or
Well, this would be a very, very next step. The problem the main constraint right now is the additive manufacturing of this storage that we are developing. Okay, that for a very big scale, there are still improvement of the technology that has to do. So of course, the idea will be to make something bigger, but for a pilot scale, that's hard.
It's a metal 3D printing. It's a really new technology. There are few manufacturing facilities in Europe that we know, and fewer than that. There are very few facilities that are able to do a 1 meter by 1 meter by 1 meter design. So now the hard part of the project is getting this tank built.
Yeah, well, a project without a challenge is not a fun, right? So,
Yeah.
Thank you so much to the University of Lleida team for joining us and sharing your work. If you want to learn more about SUSHEAT, our test developments, or follow the progress of the full-scale prototype, visit susheat.eu and check out our latest blogs and updates. And don't forget to subscribe to the channel so you don't miss the next episode. Thanks for watching and see you soon!